Hello everyone, my name is Hiroshi Aginuma. I'm the CTO of Locus Blue. Today I'll be presenting on the topic Accelerating Digital Construction in Japan with ScanX, a startup's journey to a successful exit. The title and the content has changed slightly, however the point is still the same. I'm excited to share our story with this community, and I hope it offers valuable insights and inspiration. A little bit about me. I'm from Japan. I've been working with 3D and geospatial tech for almost 10 years now. It's been a really exciting journey. About my company, Locus Blue is a startup product company based in Tokyo, Japan, and founded in 2019 by our CEO, Satoshi Miyatani. Since our founding, our product has been ScanX that I'll be talking about mainly today. In April 2024, Locus Blue was acquired by Zenrin. Zenrin is a leading map data provider in Japan, known for a car navigation, residential maps, and now autonomous vehicle data provider. We're excited to be working with them to bring ScanX to even broader audience and also collaborating on the point cloud classification discipline. ScanX is a cloud-based point cloud processing software. Although there are quite a few geospatial analysis features, here's the three main features of the product. First, accessibility of web-based platform and user-friendly design. Second, automated point cloud classification that drastically reduces manual effort and technical complexity. Third, cloud-based processing and enabling scalable and high-performance workflows without the need of high-spec local machines. Since this conference is more technically focused, I'll first walk you through the technical setup behind some of ScanX's key features. Starting with point cloud visualization and mapping, ScanX allows users to input their spatial coordinate system, including height reference, to accurately place point cloud data in its real-world location. We also integrate Cesium world terrain to display 3D terrain, making it easier to align the scanned area with the unsurveyed surroundings. Additionally, we provide a user-friendly interface for entering Japanese spatial coordinate systems, which is especially important for our domestic users. Next, point cloud classification. Our algorithm automatically classifies point clouds into key categories such as ground, buildings, vegetation, electric wires, and moving objects such as car and human being. We use many advanced pre-processing tools for point cloud classification task itself in the server using Python libraries, MATLAB, and executables. We use Cesium 3D style to apply colorization based on classification results and to enable filtering by class directly in the viewer. In addition, we modify the default point shapes using GLSL shaders, giving users a more intuitive visual representation. Our point cloud tileset parameters are dynamically optimized based on the size of the dataset, and we also allocate the optimal AWS computing instance for it accordingly. This diagram illustrates the user interface and the flow for converting various spatial data formats when importing them into ScanX. Currently, ScanX supports 10 spatial data formats, including JLAN XML, which is widely used in civil engineering projects in Japan, and DXF, which comes in many versions and contains diverse attribute structures. However, these formats are not natively supported by Cesium SDK or self-hosted right now, so we implemented workarounds. For JLAN XML and DXF, we developed a custom converter that transforms it into OBJ format, which is compatible with the Cesium 3D tiler. Then we will leverage Cesium's existing tool to convert OBJ to GLTF and feed it to Cesium 3D tiler. At the point we implemented feeding the OBJ data to the model tiler, there was a limitation on the visualization. Therefore, we only use model tiler for larger data sets as of now. Last feature in the section, soil volume calculation. In the left GIF image, it is showing the result and visualization of the cut volume. First, the user draws a polygon and finalizes the calculation. The calculation method is grid-based triangulation. It creates a grid on the top of the polygon. Each cell of the grids gets its x, y, and z using the function sample height most detailed of a scene class in Cesium.js. For triangulation, we use function in turf.js. Then we calculate the volume difference between the plane and covered point cloud. It also draws vertical line using polyline so that the user can visually confirm the accuracy of the volume calculation. The right GIF image shows the fill volume, which is under the polygon. These soil volumes will help users to know how much they could cut or fill soils during the excavation process. You might have wondered, how did you find the market fit and problems to provide the right solution? I will walk you through each of these perspectives to provide a clear context of ScanX positioning. Let's start with social perspective. As you can see in the graph, Japan's population peaked out around 127 million in 2004 and has been declining ever since. By 2030, just 5 years from now, the population will have dropped by over 1 million. Looking further ahead, in the next 25 years, Japan's population is projected to fall below 100 million. What's more concerning is that around 40% of the population will be over the age of 65. Economic perspective, in the past, construction projects were often completed through long hours and sheer determination. However, that approach is no longer viable. New labor regulations now impose strict penalties for excessive overtime. Specifically, monthly overtime is capped at 40 hours, and the annual limit is set 360 hours. As a result, companies can no longer rely on extended working hours to maintain output. To sustain gross production levels, the industry must now shift towards smarter, more efficient way of working, placing even greater importance on digital tools and automation. The political perspective, the Japanese government has implemented new regulation requiring the use of 3D datasets in large-scale construction projects. Traditional 2D blueprints are often complex to imagine the actual output and require deep domain expertise to interpret. By adopting 3D technologies, project stakeholders, including non-engineers, can more easily understand design intent through 3D visual models. These government-led initiatives are expected to significantly accelerate the adoption of 3D software throughout the construction industry in Japan. 2 points from the technological perspective. It might go out without saying, but Cesium has been a major game changer in geospatial dataset visualization. It's an excellent platform for point cloud visualization, and I believe the adoption of Cesium Toolkit has gradually gained traction across the global AEC industry. Another key technological shift is in point cloud acquisition. Traditionally, 3D scanning was costly due to the need for expensive specialized equipment. But that's rapidly changing. Devices like the DJI Xemius L1, iPhone LiDAR, and so on are making 3D scanning more affordable and accessible. Now, how do we find the deep problems of our users? How do we strategize our solution that really fits to our customer? I'd like to show how we did it and what it is. Well, macro analysis can be done from your laptop or office. Building a truly innovative, user-friendly product requires more. You should visit potential customers and conduct plenty of user interviews to gather primary first-hand insights. It's important to observe their actual working environment, what their office looks like, the tools they use, and their laptop specs. Of course, the ideal is to experience their work directly, but that's not always practical. So do what's feasible within your budget and time. At ScanX, our product team conducted 34 user interviews in just 1 year. These interviews have been crucial in shaping features that truly solve real problems. In later phase, we build prototypes and bring them directly to user for usability testing, observing and recording their interaction from behind to capture authentic feedback. Back in the team, we brainstorm ideas based on the first-hand insights to continuously refine the product. Through extensive user interviews in the early moments, we found 3 main pain points. While there were already handful 3D software products available in Japanese market, we find issues in them. First, sharing 3D dataset was not straightforward, especially in environments where collaboration is essential, showing clear room for improvement. Secondly, cleaning point cloud data, such as noise removal or classification, was a time-consuming process that required manual specialized skills and software. In addition, most 3D software solutions were desktop-based and required high-spec computers, which added to the cost and complexity. Lastly, strict licensing models made it difficult for organizations to scale usage across their teams efficiently. Bringing all these insights together, we develop a value proposition. The solution ScanX offers can be summarized into 3 key points. First, accessibility and user-friendly design. The accessibility is strongly supported by Cesium.js and Cesium self-hosted. Because it is very good at its rendering engine, ScanX project can be accessed through laptop, tablet, and even smartphone. Also, as explained earlier, we make sure to invest on user interviews to design a good UI/UX. Second, automated point cloud classification. This is where we provide the most value, although most of our users are mainly interested in ground surface or DTM. We classify other objects as well, such as electric wires and vegetation. Third, cloud-based processing. After the point cloud data is uploaded, all the heavy computation happens in the cloud. This means our users don't need to invest in multiple high-spec computers to scale their operations. The Japanese government is actively promoting the use of advanced digital workflows that leverage 3D models. This process is roughly visualized in the slide. It begins with point cloud acquisition, followed by ground surface extraction or classification. Then design models are created in the CAD and imported into the ScanX. Calculates full volume, and finally, the excavated site is compared against the 3D model design for quality inspection. All of these steps are supported within ScanX. Of course, we continue to improve and expand our features that needs improvement. But ScanX already addresses the most critical pain point cloud classification and project sharing. We significantly reduce operational time for classifying the point cloud into the user needs, such as ground. We also provide analytical function on the top of classified point clouds, such as soil calculation, and we also have tree attribute analysis, and detecting the distance between the vegetation and electric wires. Civil engineers and technicians often need to share large data sets across teams and stakeholders, and point clouds are notoriously heavy and hard to manage. ScanX solved this problem by using Cesium's 3D tileset. Last but not least, in the last section, I'd like to share the voices of our customer to show the evidence of the product market fit. Our user, Hagihara Constructions, says ScanX sharing feature is a major strength as it runs smoothly in the browser, unlike other slow services, and helps reduce the stress of not being able to show point clouds on site to clients. Our user Daya Nippon Consultant, says what used to take 2 to 3 days now takes few hours with ScanX, calling it tens of times more efficient overall. There are over 10,000 projects created in ScanX. We are still growing throughout Japan. We haven't given up going overseas as well. In fact, we never forgotten we have one user in Malaysia already. Our rough plan after M&A. So lastly, we move forward as part of Zenrin Group. We're excited to deepen our collaboration in a couple of key ways. First, we want to spread our customer-first mindset and lean startup approach throughout the company, bringing more hands-on culture. And second, we're looking to unlock even more value from Zenrin's massive point cloud datasets by applying machine learning that we're doing, taking point cloud classification to the next level. Here are the takeaways for startups. I'm excited to chat with you all during the rest of the conference. That's all from Locus Blue. Thank you for listening.